In recent years, we've witnessed a dramatic shift in how artificial intelligence is built and deployed. Gone are the days of rigid, rule-based programming systems. Today, natural language-driven workflows, powered by advanced large language models, are transforming the landscape. This evolution has opened the door to agentic AI systems that can interpret, decide, and act using plain language instructions. But what does it really mean to build with agentic AI? And how do single-agent and multi-agent systems differ in practice? In this video, we'll explore these questions using real-world examples and hands-on frameworks to illustrate the power and challenges of agentic AI. The core of agentic AI is programming with natural language. Instead of writing explicit, step-by-step code, developers now instruct large language models to route data and perform actions using everyday language. This approach allows for greater flexibility and adaptability, especially in tasks that require understanding nuance or handling ambiguity. However, just because a language model can interpret complex instructions doesn't mean it always gets things right. Data integrity and fact validation remain critical challenges. As we move forward, it's important to understand both the strengths and limitations of this new paradigm. To make things concrete, let's consider a practical use case: building a research agent for tech news. This agent's job is to find trending topics in technology, determine what's newsworthy for a specific user persona, and summarize the findings. By leveraging APIs that gather what people are discussing and sharing, the agentic system can sift through vast amounts of structured data. The focus here isn't just on the data source, but on how the agentic system processes and prioritizes information to deliver meaningful insights. Large language models, at their core, act as a communication layer between users and structured data systems. They interpret user requests, interact with APIs, and generate responses. However, their effectiveness depends heavily on the quality of the data they access. If the data is messy or incomplete, the model may produce inaccurate or fabricated results. This mirrors how humans operate. We do our best with the information available, but our output improves with better resources. Integrating LLMs with reliable data sources and tools is essential for building robust agentic systems. Agentic AI shines in scenarios where interpreting nuanced language is crucial. Think customer service, research, or collaborative workflows. For highly structured tasks, such as extracting numbers or performing calculations, traditional programming and automation often remain more efficient. The real power of agentic AI emerges when it's combined with conventional approaches, allowing systems to adapt to messy real-world input while leveraging the precision of programmatic logic. Knowing when and how to blend these methods is a key skill for modern AI developers. There are many frameworks available for building agentic AI systems. While tools like Crew AI and AutoGen are popular starting points, LangGraph stands out for its technical depth and graph-based approach. Built on top of LangChain, LangGraph offers developers a flexible way to design complex agentic workflows. Although it introduces several abstractions, learning how to use and customize these frameworks can provide valuable insights into system design and control. Even if you prefer building from scratch, understanding these tools broadens your perspective. A single-agent system revolves around one large language model, equipped with a set of tools and a system prompt. The agent decides which tool to use and when, based on the user's request. This setup is fast and straightforward, making it ideal for beginners. However, control can be an issue. Even with detailed instructions, the agent may not always follow the intended workflow or use all available tools effectively. The simplicity of single-agent systems is both their strength and their limitation. Let's walk through building a single-agent workflow for our tech news research agent. Using LangGraph, we set up a project structure with a dedicated agent, utility scripts, and tool integrations. After configuring the environment and installing dependencies, we launch the workflow in Langsmith Studio. Here we create an assistant using the Gemini model and provide a start message detailing our interests. The agent quickly processes the request, checks trending keywords, and summarizes the findings. While the results are prompt, they may lack depth or miss certain nuances, especially as complexity increases. The output from our single-agent system is a concise summary of trending tech topics, such as company news and industry shifts. For example, It might highlight Apple facing scrutiny over App Store practices or Meta undergoing layoffs in its AI division. While informative, the summary may not dig deeply into each topic or provide comprehensive context. This limitation becomes more apparent when users require in-depth research or multifaceted analysis. The agent's ability to probe further is constrained by its single-threaded approach. A key insight is that agentic systems don't automatically think like humans. They require careful orchestration to achieve the desired outcomes. While single-agent setups work well for straightforward queries, more complex research tasks demand a structured workflow. This can involve breaking the process into discrete steps or assigning responsibilities to different agents or teams. Human oversight remains important, especially for quality assurance and refining results. As we move toward more sophisticated systems, orchestration becomes a central design challenge. Multi-agent systems introduce a new level of complexity and capability. Here, multiple agents, each with specific roles and toolsets, collaborate to achieve a common goal. For our tech research use case, we set up two teams, a research team and an editing team, each with several agents. By limiting the scope of each agent and providing clear instructions, we enhance control and precision. Advanced models, like GPT-5, can be used for summarization, while lighter models handle data gathering. This division of labor mirrors real-world teamwork and leads to richer, more reliable outputs. Setting up a multi-agent workflow requires careful planning of architecture and data flow. In our example, each agent accesses a specific set of tools and contributes to a shared research pad. The editing team refines the findings, and a final summarizer agent produces the comprehensive report. This approach allows for dynamic routing of tasks and more thorough coverage of topics. However, it also introduces challenges, such as increased setup time and the need for robust error handling. The payoff is a deeper, more nuanced analysis that single-agent systems struggle to match. The final output from the multi-agent system is a detailed research summary, complete with key happenings, analysis, and context. For instance, it might report on government contracts for AI-powered surveillance, platform competition, and consumer trends shaping product roadmaps. The summary is not only more comprehensive, but also better structured, reflecting the collaborative effort of multiple specialized agents. This richer output demonstrates the value of multi-agent orchestration, especially for complex research and decision-making tasks. Even with a strong data source, building effective agentic systems is an ongoing process. Error handling, memory management, and state separation are all areas that require attention. For example, isolating short-term memory for each agent or team can optimize performance and reduce costs. Adding guardrails ensures agents use their tools appropriately and summarize findings concisely. As the field evolves, continuous refinement and experimentation are necessary to achieve the best results. In summary, Agentic AI represents a powerful shift in how we build intelligent systems. Single-agent workflows offer simplicity and speed, but are limited in depth and control. Multi-agent systems, while more complex, enable richer, more reliable outputs through collaboration and specialization. The choice between these approaches depends on your goals, resources, and the complexity of the task at hand. As you experiment with Agentic AI, remember that clean data, thoughtful orchestration, and ongoing refinement are the keys to success.